Hello everyone. So as you can see, you are not seeing my face first, which is probably making some of you happy, and I guarantee you with the way I look right now, it probably makes you greatly happy. So anyway, we're letting Olaf start this lesson. This lesson is going to be chapter 5.3, examples 5 and 6. And you are going to need your Trig identity sheet and your unit circle out for this lesson. So make sure you go ahead and grab those quickly. I'll give you a second to do that. So first thing I said is unit circle. So hopefully you have found that. And again, the Trig identity sheet. So let's go to example 5, which is the very start. And you will see that it says solve by rewriting using a single trigonometric function. This is why it's important to have your Trig identity sheet out first. What I'm going to do is I'm going to start by just rewriting the problem. Oops, let me make sure I get my pen capability out here. Pen, there we go. Okay, all right, so I'm going to rewrite my whole problem. Now, I see it's going to be much easier to rewrite cosine squared x as in terms of sine, because I don't want to have to deal with rewriting two items on the other side. So I'm going to give you a second, take a look at your trig identities, and you're going to be able to tell me pretty quickly, most of you will probably be able to tell me right away without even looking at your trig identity sheet, what cosine squared x equals in terms of sine. So I'm going to first write the left side. Then I'm going to change cosine squared x to 1 minus sine squared x. So hopefully you figured that out just by looking at your trig identity sheet. Remember, it's a Pythagorean identity that's been manipulated, just rewritten so that they're equivalent to each other. So now what I need to do is treat this like a quadratic and move everything over. And so I'm going to move everything from the right to the left. And I'm going to start by adding sine squared x. So that would be a 2 sine squared x, because I'm adding sine squared x to both sides. Okay, now I need to move that 1, because in quadratic form we need to set it equal to 0 so we can actually solve. So I'm going to now subtract 1. So what that gives me is 2 sine squared x minus sine x equals 0. This is nice because we don't have to factor it like a quadratic, so it's a little easier kind of to start this concept. So first I need to figure out what is common to term 1 and term 2 so I can factor it out. Well, I know that sine x is part of both, so I'm going to take out a sine x, which means if I take a sine x out of 2 sine squared x, I have 2 sine x left. And if I take a sine x out of negative sine x, I have a minus 1 left. When all else fails, if you're confused as to how that works, just multiply them back together. This times this would equal this. This times this would equal this. So that should help you. So now I'm just going to get rid of those so it doesn't create confusion. So now I have two equations here. Sine x equals 0 and 2 sine x minus 1 equals 0. So what I'm going to do now is go to another slide so we can continue our work. So let's move on to this. So again, sine x equals 0 and 2 sine x minus 1 equals 0. So I am going to need to solve the right side here algebraically. So first it's going to be adding 1 and then dividing by 2. So that'll give me sine x equals a positive 1/2. So at this point, we need to go to our unit circle and figure out where sine is 0 and 1/2. So again, sine x equals 0 and sine x equals 1/2. Well, again, sine goes to y. So I'm looking for a y value, first of all, that is 0. Well, I have that at 2 places, at 0 degrees and at 180 degrees, or pi. So my answer for the sine x equals 0 is going to be 0 and pi, because we're doing it on an interval of 0 to 2 pi, where 2 pi is, where 0 is included, but 2 pi is not. So we just list 0 and pi for that one. Now, I have to remember that sine x equals 1/2 also, and that means it has to be where sine is positive. Well, we know that sine is positive in quadrants 1 and quadrants 2. So I'm going to look at quadrant 1 and find where sine is 1/2. Again, it's the y value. Well, sine is 1/2 at pi over 6. Then I'm going to look in the second quadrant for where sine is 1/2, and that is at 5 pi over 6. So we add the additional answers of pi over 6 and 5 pi over 6. So I go back to my problem and I put those answers in. Oops, wrong slide, we wanted to go here. So we've got pi over 6 and 5 pi over 6. And then over here we have 0 and pi. And these are the answers that you were looking for this particular problem. So to continue on, I want to show you something on this slide. So we found these answers of 0, pi over 6, and 5 pi over 6. So this is another way to check. You can put them on the calculator and you'll actually see where they intersect. But if you notice, sine squared minus sine x plus 1 and cosine squared x intersect at both 0, pi over 6, 5 pi over 6, and pi. And that is what the solutions are, is where they intersect. It's kind of like the old system of equations that you used when you were in Algebra 2, if you remember that. The solution where they're equal to each other is where they intersect each other. So hopefully that helps a little bit. So let's move on to what we would do as a soperative problem. And go ahead and pause your video and figure out how to solve this. And unlike yesterday where I wasn't paying attention to instructions, today I'm looking, and we're looking for an interval of 0 to 2 pi. So go ahead, pause your video, and take a second to solve. All right, I'm done pausing. Hopefully you got that solved after you paused. And so now let's work through this and see which answers are correct. So on this problem, I think it's going to be really difficult to change cosine into terms of sine without doing some more dramatic information. But I do know that sine squared x will be able to change to terms of cosine. So I'm going to start, instead of rewriting the whole equation again, I'm just going to start by changing sine squared x to its Pythagorean equivalent, which is 1 minus cosine squared x, which equals cosine x plus 1. So what I'm going to do now is just distribute my 2. Oops. All right, 2 minus 2 cosine squared x equals cosine x plus 1. So now I need to move everything over to the one side and set it equal to 0. Now, because this is negative, and I just hate to work with negatives as leading terms, I'm going to move everything from the left to the right. So that means I'm going to add 2 cosine squared x, and subtract 2. So by adding 2 cosine squared x, I will have 2 cosine squared x on the right, plus cosine x. And then by subtracting 2, 1 minus 2 gives me a negative 1. So now I have moved everything from the left to the right, and now I can go ahead and factor. And as you know from yesterday's video, or for some of you it might be a week ago, or it depends on when you watch this, I'm going to use my diamond method because I always do, especially when I have a leading coefficient that is greater than 1 and we have a 2 there. So I'm going to create my box, my diamond. And we know that my A is 2 and my C is negative 1. So I'm going to put a negative 2 here. So 2 times negative 1 is a negative 2. And that's not a very good negative 2. So I'm going to redo that. Okay, negative 2. That's better. Okay. And then we know that my B, because there's no number there, has to be a 1. So 2 numbers that multiply to negative 2 and add up to 1 would be 2 and negative 1. Okay, so I'm going to use those numbers to break apart my middle term. And for some of you this is redundant, but some of you are still trying to understand it. So I want to make sure you get what I'm doing. So I'm going to pick since 2 goes into 2, I'm going to list that one first. So 2 cosine squared x plus 2 cosine x minus cosine x minus 1. So again, just like the last time I showed you this, my 2 is here and goes here. And my negative 1 is here. So that's what I've done. I've just split them apart. Okay? So let's go back and let's put in our little imaginary line that breaks the equation in half so I can factor each half. We call this factoring by grouping. So our first group, I'm going to factor out what's common to this, and that's a 2 cosine x. That leaves here a cosine x plus 1. Okay, now my goal on the right side is to have a cosine x plus 1 as well. So I'm going to take out a negative 1. And I'm going to have a cosine x plus 1 on the inside. So if I multiply my negative 1 times cosine, it'll give me a negative cosine x. If I multiply my negative 1 times a positive 1, it will give me a negative 1. So hopefully that helps you understand a little bit better about what we're doing. So now cosine x plus 1 is one factor. Okay, and once I have that, because it's only a factor once, I can cross it out and see what's left. And that is 2 cosine x minus 1. So those are our two solutions basically, but we have to algebraically solve them. So I don't have another slide over here, so I'm going to come over here and do this. So cosine x plus 1 will be cosine x equals negative 1. And 2 cosine x minus 1 will end up being cosine x equals 1/2 after we do the algebra. So I am looking for where cosine equals a negative 1 and a 1/2. So I'm going to go back, and again, it's on an interval of 0 to 2 pi, so we could have a few answers here. So I'm going to go back to my unit circle, and I probably have a little erasing to do, but that's okay. I'm getting better at it. Eraser. Yes. Sorry, it's the little things in this coronication that we have, right, that make me happy. Okay, so again, cosine x equals negative 1, and cosine x equals 1/2. Well, I know there's only one place on this unit circle where the x, because remember cosine is the x value on the unit circle. So I know there's only one place where cosine will equal negative 1, and that is at pi. You could always pause this video if you're trying to solve them without my help and then come back in again and see if the answers that I'm giving are what you came up with when you paused it. It might help. So anyway, we have the first one. So that means pi is one of our solutions. Now, again, cosine x is positive. Well, where is cosine x positive? Cosine will be positive in quadrant 1 and quadrant 4. And you can tell that just from the descriptions, but hopefully you can remember that x is positive in quadrant 1 and 4, and that will help you tremendously. So I'm going to go look for cosine x equals 1/2. Well, I have that at pi over 3 in the first quadrant, and then my x value is 1/2 at 5 pi over 3 in the fourth quadrant. So pi over 3 and 5 pi over 3. Okay, why does it keep doing that? All right, pen, 3. There we go. All right, so let's go back to the problem and see if our answers, let's see where that is. Multiple choice. Oh my goodness, guess what? I would believe it is D. So now what I want to do is go and check the slide that is next, because it will tell me if we are correct. Let's see. Yay! Yay! We got it right. All right, I know you're super excited. I know I am too. Okay, we now have example 6. So you could probably take a little break, pause the video, go get a drink of water or a snack, so you can come back and join us for example 6. Okay, let's get started on example 6. This one is going to have an additional step at the end that's really, really important, because if you notice here, it says that we're solving by squaring. And solving by squaring means that we could bring in some extraneous solutions. We have to be able to check our answers. So we will do that together as we get going. So the first thing I'm going to do is I am going to rewrite this equation. Now, I could square all of this right now, but it would drive me crazy because I'd have sines times cosine and all that stuff. So what I'm going to do is I'm going to move cosine x over for right now. And you'll see my method to my madness as I get going. So first I'm going to add cosine to each side. So when I do that, and then I decide, okay, now I'm going to square both sides. Okay? So when I do that, I will have sine squared x. Now, some of you automatically will go and say 1 plus cosine squared x. Be really careful, because remember, this is 1 plus cosine x times 1 plus cosine x. So you're going to have to FOIL it. So that means I'm going to have a 1 plus 2 cosine x. Again, that's because of cosine x times 1 plus cosine x times 1. Then I'm going to have plus cosine squared x. Okay, and this is just me, but I like to have the constant last, so I always rewrite it. That's just me though. I'm going to switch and put cosine squared x plus 2 cosine x plus 1. Now, we're going to use a strategy that we learned in example 5, and we're going to change one trig function to be equivalent to another from our Pythagorean identities. So I'm changing, if you've thought about it already, I'm changing sine squared into what? Yes, for those. I'm going to start calling out names, just hoping you're watching. So yeah, in period 3, Zach, Hudson, Kaiser, and Dylan, guess what? We're changing it to what your answer is, which I already know you have it. I'll pick on other people later. 1 minus cosine squared x. Very good, you guys. You're so smart. So, cosine squared x plus 2 cosine x plus 1. Now, I have to treat this like a quadratic again, so I'm going to add cosine squared x, and I'm going to subtract 1, so that I can set this equal to 0. So by adding cosine squared x, I now have a 2 cosine squared x. I still have a 2 cosine x. And by subtracting 1, I have 0, so I don't have to write anything else. And then I have to factor. So 0. And what's common to both this and this? Well, obviously 2 cosine x. So that leaves behind a cosine x plus 1. All right. So now I'm going to write them separately. We will have, let's go to another screen because I think that'll be way better. So 2 cosine x and cosine x plus 1. So we have 2 cosine x equals 0 and cosine x plus 1 equals 0. I got to double check. Hang on. Did I do that right? Yep. Cool. All right. All right. So 2 cosine x equals 0 is pretty easy because that just means cosine x equals 0 because we're dividing by 2. And then subtracting 1 on the right side. So cosine x will equal a negative 1. So if we want to, let's go look at our unit circle again and figure out where these things happen. So unit circle, again, forgive me, but I'm going to have to erase. So first I have to find it. Okay, because it's at the very beginning. So here we go. All right, going to erase. Yay, oops. Okay, so I've erased. And now I have this one, and I need this one, and I need this one. Okay, very good. You don't even know what I'm pointing at, but anyway. So cosine x will be the x value. And we need cosine x equals 0, and cosine x equals a negative 1. So what I need to do now is figure out where is cosine x 0? Well, cosine x is 0, and 0 is only going to happen on the x-axis at 0. So we have pi over 2, and we have 3 pi over 2. So I'm going to put pi over 2 and 3 pi over 2. Then I've got a cosine x at negative 1. So, or that is negative 1. The only place that happens is at pi. So we have 3 answers that we have to check. We have a pi over 2, we have a 3 pi over 2, and we have a cosine. At pi. Okay, so let's go back to our problem. And let's get to the right slide, which is right here. Okay, and actually what I want to do is go back to the very original to show you how this works. So let me erase. Okay, so when I say let's check our answers, we're going to start by checking pi over 2. And how you do that is you put, instead of x, you put sine of pi over 2 minus cosine of pi over 2 equals 1. And we'll see if this is an extraneous solution or not. If you have your unit circle out, you should know that the sine of pi over 2 equals 1, and the cosine at pi over 2 is 0, and so 1 equals 1, so that one checks. So pi over 2 is good, okay? Now we're going to check pi over 3. So 3 pi over 2. 3 pi over 2 minus cosine 3 pi over 2 equals 1. Well, the sine at 3 pi over 2 is negative 1. The cosine at 3 pi over 2 is 0. And negative 1 does not equal 1. So 3 pi over 2 is not a solution. And then our last one to check is pi. So the sine at pi minus cosine at pi equals 1. The sine at pi is 0 minus cosine at pi, which is a negative 1. Well, a negative 1 is 1, equals 1, so that checks. So pi is also a solution. So the final answer for this particular problem would be pi over 2 and pi. And that's how you check that one out. So, okay, so now we're going to move to our Socrative type question. And I'm going to have you pause your video. So this one's going to take a little bit of time to put together. So I'm going to take it to another slide so we have a little bit more room. Let's go over here. And I already have it written out. Let's see if I can move it up a little bit. I just happen to know this is a little bit messy, so let's start from there. Okay. So we've got 1 plus cosine x equals root 3 sine x. And I'm going to square it. So when I square it, I'm just going to go ahead and do it. Cosine squared x plus 2 cosine x plus 1. Remember, that's the multiplying of 1 plus cosine x times 1 plus cosine x. Then when I square, so this is squaring both sides. When I square the root 3, that is 3. When I square the sine x, it is sine squared x. Well, I need to change sine, like we did in example 5, to terms of cosine, so that I can solve this a little bit better. And so sine squared x is the same as 1 minus cosine squared x. Cosine squared x plus 2 cosine x plus 1 is still my left side. So I'm going to distribute. Then I'm going to move everything from the right to the left. So now it will be 4 cosine squared x plus 2 cosine x minus 2, because the 1 minus 3 is negative 2. All equals 0. I'm going to use my diamond method. So my a times my c is negative 8. And my b is 2. So I have to have two numbers that multiply to a negative 8 and add up to 2. Well, that would be 4 and negative 2. And you get that through guessing and checking pretty much, knowing your factors. So 4 goes into 4, so I'm going to go ahead and break up my middle term and start with 4 cosine x plus 2, actually minus, so let's back that up a little bit. Why did I go so far? I don't know. Let's try it again. 4 cosine squared x plus 4 cosine x minus 2 cosine x minus 2, all equals 0. So just like before, I took my 4 and put it here, and my negative 2 and put it here. So let's go back. All right, so now I'm going to put my little imaginary line. I'm going to break my equation. So it's going to be 4 cosine. I'm going to factor out a 4 cosine x. That leaves me a cosine x plus 1. Then over here, I'm going to factor out a negative 2. And that leaves me with a cosine x plus 1. So that means I have cosine x plus 1, which means cosine x will equal a negative 1. But it also means I can cross those out. And what is left is 4 cosine x minus 2, which when we add the 2 and divide by 4, cosine x will equal 1/2. So we need to go to the unit circle and find, okay, get my pen back. Okay, so we're looking for cosine x equals 1/2. And cosine x equals negative 1. Well, again, we know that cosine x is negative 1 at pi. So that one's easy. Cosine x at 1/2, that's going to be in quadrants 1 and 4 because it's positive. So I'm going to find my x value, so that's pi over 3. And then also 5 pi over 3. we're just going to check these right in our, well, let's go back and figure it out. So we know that the cosine of pi over 3 and the cosine of 5 pi over 3, and let's see here, and we've got pi. So those are the ones we're going to check when we go back to our equation. So let's do that real quick. Let's go back. Okay, so if you have your unit circle out, right now it's looking like it could be 2 answers. Maybe C. I'm not sure. Maybe C. And maybe D. But we got to check them. So what we're going to do is we're going to go and we're going to check each angle. So 1 plus the cosine of pi over 3, which is our first one, equals root 3 times the sine of pi over 3. Okay, so I'm going to look at my unit circle. What's the cosine of pi over 3? It is 1/2. So 1 plus 1/2. And then root 3, and then what's the sine of pi over 3? Well, the sine of pi over 3 is root 3 over 2. So this will be 3/2 when we add it together. And when they multiply these two together, it becomes 3 over 2. So that checks. Yay! So we know pi over 3 works. Very good. All right. So let's erase that. Now we're going to check pi. So 1, okay, really, 1 plus cosine at pi equals root 3 times the sine of pi. So, well, the cosine at pi is -1, okay? And the sine at pi is 0. Well, 1 plus -1 is 0, and root 3 times 0 is 0. So yay, that one checks as well. So pi is good. So now we've got to figure out if 5 pi over 3 works, because then that'll tell us whether our answer is C or D. So let's erase this. Very good. All right, and then I'm going to, it's going to be 1. Okay, darn it, I didn't even change. Oh, yes, I did. Gotta quit arguing with myself. All right, here we go. So 1 plus the cosine at 5 pi over 3 equals root 3 times the sine at 5 pi over 3. Well, I'm looking at cosine of 5 pi over 3, and hopefully you're looking at your unit circle, and I see that the cosine of 5 pi over 3 is 1/2, right? So that's going to equal 3/2. Now, the sine of 5 pi over 3, when I look over there, it is negative root 3 over 2. So what this will give us is a negative 3 over 2, which means they're not equal. So 5 pi over 3 is extraneous. And that's why you have to check problems where you square. Extraneous. Okay, all right. So I think our answer is actually C. So what we're going to do is we're going to check the final answer. Let's go see what it says. Yay! If you only knew how many times it took this to happen, I'm going to be doing a lot of editing once I'm done with this answer. Okay, the final slide for you, my little cherubs, and if you don't know what that means, hopefully you do, it means little angels, is your homework, the dessert. Here is your dessert and a gift compliments of me. Homework. Homework. All right, you didn't get to see my face today, but you heard my voice quite a lot. I hope you're staying safe. I miss you all. And there will be more to come. So the homework is posted on Schoology, and I'm looking forward to more pictures of your homework being turned in. Take care, and my best wishes to all of you. I'll see you soon. Take